Welcome to this video. This is Saeed Ahmed from Toronto, Canada. So we are discussing implementation of a research paper in graph neural network, graph mining, right? So we are doing stock market prediction, stock price prediction using graph theory, machine learning, and deep learning, right? Graph convolutional network and CNN. I think this is the fourth video, right? We did the first, just the overview. Second, mostly on the data set and some creating some graph. I think because it's about stock price prediction, but depending on the stock relations, we created some graph, right? And then another video was this graph. We just converted in such a way so that it can be used as part of a graph convolutional neural network, part of the input of a graph convolutional network. We also created graph convolutional network, just one of the basic thing. So for experimentally, that was not genuinely aligned for the purpose, for the research or for the work, right? It was just a dummy placeholder kind of graph convolutional network. Our goal was just okay, take a graph convolutional network and see if I can feed the data graph, and as part of the graph node or that represent the stock, we also created another data structure to feed the historical prices, right? So in this video, what I will do? In this video, I will just do some code cleanup, right? This code cleanup. So I think the code cleanup, one of the aspect will be when I was taking a look into graph neural network. Although I work with some graph mining or some other related things, but this specific graph convolutional neural network or graph neural network, I did not work in this way. So I'm just checking some ideas. So I found how to do classification using graph neural network or graph convolutional neural network. So I took some ideas from there, and that was some classification problem. But our case is stock market price prediction. So I took the ideas, converted the classification cases into regression cases. So I'll be just removing those classification related aspects to that. Probably one of the goal for the cleaning of this video. Okay, so after this cleaning, in the next video, I think one of my important goal is to make the graph convolutional neural network aligned for this work so that I can really predict it, right? The stock price prediction, that's a core goal. So aligning that for the task for this paper, that is the primary goal, right? So if I can do that, then I can do the other step. Those will be the easier part. Now, one caveat though. Now, at this point, I'm just using only 10 stocks, right? Only 10 stocks. And for that, even if my graph convolutional neural network is perfect or good, using these 10 stocks, it may not give me good output. So to some extent, I will be, as for next step, I will take the graph convolutional neural network to the next step, and then on the parallelly, I will be improving or making the data set big enough, right? Data set big enough so that when the model is good, it can create some correct result, right? Now, if the model is good, but I just feed only small data set, I will not know whether the model is good or not. Okay, so yeah, I need to construct the model and the graph convolutional network, take it to the next step. However, parallelly, I also will need to take my data set large enough so that when my model becomes good, whether I can identify it, whether it's good or not, that probably is a difficult thing to do. But still, if I feed the data and large data, and if I can see some output, then I can say, okay, okay, I have progress. So I want to take the graph neural network to the next step and the dataset to the next step, right? And one more thing I actually need to do. The way I was feeding the data, the structure is like let's see, on the time series data horizontal. Time series data is horizontal. Stock name, stock name is stock name. Time series horizontal. I think the date wise, right? Usually, the idea is supposed to be the other way around. Other way around. That means the for each column is for each stock. For each column is each stock. At this moment, each row is representing the stock prices. So I need to see the graph network that I created, whether it makes sense. Apparently, it looks like the column representing the stock prices. That is the way to go. That is the common way. Still, if the model is working or giving me some output, but it does not mean that I'm working it well. So I probably will need to debug in between, and debugging neural network, it's a little bit a tricky thing. So, but I'll need to find a way. So, okay. So one thing is remove the classification aspect of it, classification aspect of the code, wherever it is. So I want to remove this. That is one thing. And taking the graph convolution neural to the next step. It is supposed to be the next video. And adjusting the data more, and make it bigger will be another step, but that can be another video. However, making the data structure suitable to the graph convolutional neural network that I am using, I think at this moment the time series on the row wise, but I need to make it column wise and see what is the accuracy that I get. At this moment, I'm getting accuracy is totally 0, right? And one thing can be my data set is small. Another thing is probably it is not finding any correct time series for the stock prices. So those things are there, and data set is small. That is one thing. Let me see. I wanted to say one more thing on this. Okay, the structure of the neural network at this moment, it's just graph convolutional neural network with multiple layers. But I believe the paper, the way it worked, one layer is graph convolutional network, another is CNN layer, and then another graph convolution, another CNN. So I want to restructure the graph convolutional neural network as well. But that is something for me to research and find out and then modify. Okay, so let's first change the uh, classification aspect to it, the core focus of this particular video, right? So let me share. Okay. So let me share my screen. Okay, share screen means I will be sharing Google Chrome. Okay, this is what I wanted to share, right? Okay, I believe I can just restart and run all. Okay, removing the classification aspect. One thing is the target variable, right? Classification, the target variable, that is the price, right? Stock market price. The article or the code example where what I studied, that was node classification, right? My thing is not node classification, it's stock market price prediction. So that was the different multiple class. My thing is it's not class, it's just predicted some continuous values or some numerical values. So target, right? That's probably one of the thing. Previously, using the data, what they are trying to do, the target variable, they are trying to map them into different classes, and then they are using that as a target variable. For my case, I do not need to classify the target variable. So anything classification, I need to remove it. So binary preprocessing, label binarizer, that was one of the things. So train targets, val targets, test targets. Okay, target encoding. train subjects. Okay, so I might need to do a little bit more here. Yeah, I think in this case, the validation target and test target, validation set and test targets. So target encoding transform. Okay. Okay. Okay, I probably need to see what exactly they were doing. Yeah, they are doing some classification and some sorts of uh, encoding and transformations. Now I need to see in my case the what I have done, whether it is perfectly valid or not, right? Now in my case, let me see. So time series, okay. Okay, because it is coming sequentially. So the target, okay, let me, one thing is, yes, in some time series analysis, we divide the data using some windows, some window, and then the final row is the final column is the target from the historical. But in our cases, I think the series and entire series can be seen. I think it is just always evolving, and the target is always evolving depending on the previous sequences. So I probably need to put some thought what I can do, and most importantly, what the paper has done. Anyway, at the minimum, as I told, I will be removing the classification related aspects from the code. Yeah. Train subjects and train targets. It looks like I need to study the code or do some more research into how to formalize this data set to fit into the model or to fit into the overall work. Okay. So it is just a very generic graph convolutional neural network. And I actually need to use multiple layers, GCN and then CNN. So I need to go there. And in our case, let's see, softmax, right? Softmax, usually it's used for the classification, multi-class classification. So this might something that needs to be changed, right? This might something that needs to be changed here. Okay, let's keep it as is. Okay, loss function, predictions, optimizer. Okay, yeah, I believe there are more to do in terms of making it suitable for regression. So changing the models and layers, that probably definitely needs to be done. And before that, let me see if changing the data structure make any difference or not. I think this data, this was in the horizontal form, right? Horizontal time series. So Pearson graph node data. Okay, I think we can do it in terms of the graph generation. I'm using a library called Stellar Graph. Okay. Okay, Pearson graph. It is just it is not eventually used because there is no features here. So okay, Pearson graph node with data. No, I don't think I have used it. Yeah, I believe this is the one that that has got used. Let me see. Pearson graph node data edge Pearson edges. Corner. Okay, this is the one that got actually used. Let me see if I used a uh, transpose. Okay, transpose. Let me see. Probably no. Here. Okay, Pearson graph node data. Okay, or this might be right. We are thinking about 6 stocks as a training. Others will be testing or something. But this is a graph, so it is slightly uh, different. So in some cases, in graph neural network, whatever is in the training, in some way, similar or the same thing can be in the testing as well. There something. It is not absolutely what I said. I'll not say there is absolutely correct sentence, but yeah, there is a flavor that whatever is the training can also be in the testing. You test the nodes or the stocks. It can be in testing because there are some correlations and connections and graph edges. So if we just keep in the testing only the newer ones, uh, okay, that may not be the ideal case, or that is not something that must have to be like that. It can overlap. It is not just like the traditional machine learning that the train cannot be in the testing, right? So there is something like this. So it looks like it may be okay, but I can still try to see. Okay, this is the node data. Pearson graph node data. Okay, where am I using this? This one. Node data is this one. Okay, Pearson graph node data. It is using that node data. Okay, let me see if I pass it here. I think it is node data. It is where we are passing the whatever. Yeah, the idea is whatever node is in the graph or those stocks, the time series. Okay, let me create it if it works. Okay, let me see. Just to keep track. Now, this might have got changed somewhere, so I'll just kernel and restart and run all. Okay. Where does it break? Okay, yeah, it probably expects it the way it is, right? It probably expects it's like this. So I am changing here. That's okay, that's okay, that's okay. Okay, let me see. Yeah, it probably worked here, right? Okay, it also is not working here. Okay, actually, this is not being used because the last graph, I think this was some experimental thing that I was doing. So this probably where it is. I'm not really sure if I was thinking to change it before. I might have changed it right then. Okay, I think one more cleanup probably I can do because I'm making many different graphs that I'm not using, right? So Pearson graph with node features, Pearson edges, right? Okay, Pearson graph with the node features. Actually, that's what I graph with feature as part of nodes. That's what I actually want. So Pearson graph with edge features. Okay, this something I don't need it. So I'll just comment it out. Okay, node data, right? Okay, this is probably what it is. You are passing the graph, but the time series, you are dividing it training testing, right? So that a graph relation is there. Now, if I just pass the data in training and testing, that probably still makes sense. The structure, you are not dividing the structure. You are just dividing the time series. Okay. So that way things I believe are okay. Okay. Apparently and logically also, really don't need to use a uh, window. It's just the entire series uh, prediction in sequence. That's how the model will learn, right? How it goes one time step to another time step, how the price is changing, and depending on that, it will learn the prediction. So I don't need just chunk and then divide, chunk and then divide. So far, it looks like it's not we don't need to work in in that way. Okay, let's move on. We did a little bit of cleaning. That was the goal. Now I believe I can try to get into the data site just to make it a little bit bigger data so that I still see that how if that has any effect on the accuracy. Okay, that's probably one of the thing I want to see, and then I'll research on the graph convolution on CNN and making those layers and structure. Uh, so probably will get some more opportunity to play around those layers so that I can see some sort of improvement in going to the right direction. At least if my data is good and if I see that this could improve the accuracy even a little bit, that could be okay. So this is something I actually will not need. Okay. It also comes from the classification ideas. So far it looks like. Okay. So let's stop this video. In the next video, I will see how can I do the data set merging thing and create a bigger data set.